Assalamualaikum warahmatullahi wabarakatuh, and every good day to everybody. So now we move to a new chapter, equilibrium of a rigid body. Okay, so basically when it's actually before this we have learned equilibrium of particle. Now we are learning equilibrium of rigid body, because in the beginning of chapter in static we analyze our problem. You can the static can be idealized as the in the particle and also the rigid body. So when the rigid body they have a content of the sizes, because in the particle we are negligible the size, we neglect the size, but it has mass. But rigid body we are considering the mass, considering the size. Okay, so in this the objective of this chapter is, the first one is develop the equation of equilibrium. So we have the equation of equilibrium for a rigid body. Before this, equation of equilibrium of for particle, which are only have a two equation of equilibrium for particle, which are total resultant force in x direction equal to 0, and total resultant force in y direction equal to 0. That one is the equilibrium for a particle, but this one is a bit different. So this one is for a rigid body. So second one, the second objective is the concept of free body diagram for a rigid body. So we need to have understand what is the basic concept of free body diagram for a rigid body, and then after we develop the equation, we can draw the appropriate free body diagram, so we can solve the rigid body problem using the equation of equilibrium. Okay, so the outline for this chapter, basically we have four subtopic in this chapter. Hopefully in this chapter we will make a two video for first session and second session. This is the final session. So the first one is a condition for rigid body, second one is a free body diagram, third equation of equilibrium and two force member. Okay, for condition of rigid body in equilibrium, for example, we have the body. So let's say the point O, acting at point O here, we have the force. So we are just this one just for the for sake of the picture. So actually resultant force, there are many forces applied at point O here, so we just take the resultant force acting from point O, so they equal to 0, and total sum or moment acting about point O is equal to 0. So the equilibrium one, the condition, the rigid body is a resultant force equal to 0, and total resultant moment about point O here is equal to 0. This one is the condition for rigid body of equilibrium. Okay, for free body diagram, so we have first a support reaction. So for example, what is meant by support reaction? If a support means by prevent the translation of body in a given direction, so then the force is developed on the body in that direction. So prevent the objects move. So they have we need to develop the force on that body in that particular direction. If rotation is prevented, a couple moment is exerted on the body. So we need to have the couple moment we have learned in the previous chapter, chapter number 4. So here we have the several picture. For A, we have roller here. So the support roller is actually preventing the if we want to make this beam just roll in this position, meaning that only in the horizontal, not in vertical. So meaning that we have the force, because we don't want to make the translation force in y direction, so it will be a force in y. Okay, so for the C is the hinge support of pin support. So we have this connection for the C, and then for D we have this acting on this particular point, so we have the force in angle. So we can break up into the X component for the force and Y component of force. So if we fix support at the wall, for example here, so if we prevent to the translation is prevent in the X component, in Y component, also the in X and Y component. So if you want to rotation, we don't want to make a rotation here, so we are couple moment we exerted on the body. So here is a couple moment because we want to prevent the rotation. Okay, you can open back your static Pearson with R.C. Hibbeler. In that particular textbook, we have the table. This table 5.1 support for rigid body subjected to 2D force system. So in this one they have a type connection, we have the reaction, so very be a reaction force, and also number of unknowns. Very important, you need to open back your textbook, and then you need to understand all the type of connection is, as well as a reaction, what the reaction is for each type of connection, and also how many number of unknown for that particular type of connection. Okay, so basically when we are dealing with the equilibrium of rigid body, we are focusing they have internal forces. Okay, what's meant by the external forces and internal forces can act on the rigid body. There will be external forces, there will be internal forces. For free body diagram, internal forces act between particles which are contained within boundary of a free body diagram are not represented. Okay, so because here, for example, this this engine, considering have too many parts, assembling part here. So each part another part, and onto another part we have the force, internal force between the parts. So we are and then we hook with these two cord, and then at the this one's the screw eye here. So the important is we need, for example, if we want to get the tension of this cord, and also we need to find the reaction at this hook, for example, for this separation. So what will be the internal force? Is it affected or not? So internal force which actually are not represented. We just we are only this subject, we are particle outside this body as the external force on the system. For example, these two tension. So how I want to eliminate, how I want to transfer, how I want to change, convert the internal forces, because this is also important to do our calculation. So as I said, each particle in this machine has a specified weight. So a system can be represented by a single resultant force known as the weight of the body. So location of force application is known as the center of gravity. So meaning that all the forces, internal forces, now we are represented as a one single resultant force as a weight. So the weight as you put the location of center of gravity here. So we have the weight W represent all the forces, internal forces. Then we have the external two forces, these two tension forces. Okay. So the procedure for drawing a free body diagram. Okay, in developing the appropriate free body diagram for our problem, we have the some procedure for drawing a free body diagram. First one is to draw outline shape. So we need to draw the outline shape. What will be our problem? Imagine bodies to be isolated or cut free from its constraint. So now we are focused on the body itself. So we didn't put any constraint or the support reaction. So draw the outline shape, and also the XY plane. XY what will be the X axis, will be Y axis, and then show all forces and couple moment as well. So identify all external forces and couple moment that act on the body. So the next one is we need to identify each loading and give dimension. So indicate the dimension for calculation of forces, and known forces and couple moment should be properly labeled with diameter and direction. So in first one is we need to draw the body itself. Then second one is show all forces and couple moment, and so we identify what will be the loading, and also to give the dimension, indicate the dimension in order to calculate the force and couple moment. So also there should be all these forces, all these couple moment which we has already known, should be properly labeled with diameter and direction. Okay, I think we stop here. Now we are continue for the next session. I think this session will be a final session for this chapter, and we give some example. Okay, thank you. See you again in next session. Bye bye.